This is part 2 of our notes for 4.4. So we are going to learn the definition of a reference angle. So if theta is a non-acute angle, okay, so that means that it's more than 90 degrees in standard position that lies in a quadrant, its reference angle is the positive acute angle. So that means between 0 and 90 degrees, or between 0 and pi over 2 radians, formed by the terminal side of theta and the x-axis. So you always want to remember here, you're always looking for the angle that the terminal side makes with the x-axis, and you always want to be finding an acute angle. Okay, so let's look at some examples. We want to find the reference angle, theta prime. Okay, this little apostrophe, we say it prime. So for each of the following angles. So the first thing that I want to do is I want to draw in my angle in standard form. So 90, 180, 270, and I know that 345 will end somewhere up here. Okay, because I know that this is 360. So this is my angle theta, and I am looking for this angle here, which is my theta prime. I know that this whole angle is 360, or whole circle is 360, and I'm looking to see what that theta prime is. So my theta prime, I'm going to take the 360 degrees, and I'm going to subtract 345 degrees. So my theta prime is 15 degrees. Okay, it's just what would complete and what that angle is between the terminal side and my x-axis. Next, I am going to sketch in my angle 5 pi over 6. I know this is 3 pi over 6, and then another 2 pi over 6 would get me to 5 pi over 6. So again, I am looking for this angle right here. This is going to be my theta prime. Right here, I can see that's pi minus this part, 5 pi over 6. So I remember that pi is 6 pi over 6, over 6. And 6 pi over 6 minus 5 pi over 6 is pi over 6. Okay, so my reference angle here would be pi over 6. For my next angle, negative 135 degrees, I go negative 90. And to get to 135, I'm going to go another 45. So again, this is my theta. And this time, I'm looking right here between my x-axis and my terminal side. That's my theta. So I can see that this would be 45 degrees. Okay, your reference angle is always going to be positive. In our last one, this sometimes confuses people because there's no degree symbol and there's no pi. But remember, if there's no degree symbol, we are still thinking that this is in terms of radians. Okay, so I know that pi radians is about 3.14. So 2.5 is probably somewhere around here in my second quadrant. So to find my reference angle, I'm going to have a full pi minus 2.5. That's my exact answer. Now using my calculator, I'm going to find that this is approximately 0.64. Okay, I rounded to 2 decimal points. Okay, so again, your reference angle is always positive, and you are looking for the angle measure between the x-axis and the terminal side. Okay, whichever quadrant you fall in. Okay, pause the video and try the 3 YouTube problems on your own. Okay, so for letter A, 210 puts us into the third quadrant. Hopefully you realize this is 180. to go up to 210, you'd go another 30 degrees. So it's 30 degrees right here. 7 pi over 4 brings us into the fourth quadrant. Okay, this little piece would be a pi over 4. Okay, our next one, negative 240. This brings us to negative 180. Going another 60 would get us to negative 240. So that's why this is 60 degrees. 3.6 is bigger than 3.14, right? So we're about right here. And so I do 3.6 and I take away the pi radians to leave me with this piece. And that's approximately 0.46. So we can continue to do this with angles that are outside of our 0 to 2 pi unit circle range that we're usually thinking about. So negative 580, that would be a full circle around. And then another 220. So another 180. And hopefully you would realize this would be 40 degrees. So our reference angle, right, to get from 180 to 220 would be 40 degrees. And for 8 pi over 6, I can see that this is 6 pi over 3 plus 2 pi over 3. So I'm going a complete circle around. That's my 2 pi, my 6 pi over 3. And then I need to go another 2/3 pi, which puts me to here. And hopefully you can see the reference angle is pi over 3. Okay, because that would be the space right here between the x-axis and the terminal side. So reference angles can be very useful to evaluate trigonometric functions. The value of a trig function of any angle can be found as follows. You find the associated reference angle and the function value for the reference angle. This is why I was saying it's so important to memorize the first quadrant and then use the quadrant in which theta lies to prefix. So prefix means to put before the appropriate sign to the function value in step 1. Okay, so let's look at some examples. So sine of 135 degrees. I know that that falls here. And I know my reference is 45 degrees. So I know that the sine of 45 degrees, I memorized that, is the square root of 2 over 2. And I know that the sine in the second quadrant is positive. All right, my all students take calculus. So I know that the sine of 135 is square root of 2 over 2. So cosine 4 pi over 3. I draw in 4 pi over 3. Okay, I know that the cosine, so I can see that my reference angle is pi over 3. I know that the cosine of pi over 3 is 1/2. But I also see that since I'm in the third quadrant, my cosine is my x value. It's going to be negative. So my cosine is going to be negative 1/2. Tangent of 14 pi over 3. 14 pi over 3 is 4 pi over 4 pi. So 1, 2, 3, 4. And then I need to go another 2 pi over 3. So that puts me in that quadrant. Again, I've memorized that first quadrant, so I know that the tangent of pi over 3 is going to be square root of 3. But and that pi over 3 is my reference angle. So I have square root of 3, but I also know because I'm in the second quadrant that it'll be a negative. Okay? Our next one, negative 17 pi over 4. That's negative 4 pi. And then another 1 pi. Okay, so I know that this is going to be that the secant of my reference angle here is pi over 4. Okay, so secant is the reciprocal of my cosine. So I know that my cosine of pi over 4 is square root of 2 over 2. I know my secant of pi over 4 is square root of 2. Okay, but I notice here I'm in my fourth quadrant. My cosine is positive in the fourth quadrant, so my secant is also positive. So my answer here is square root of 2. Okay, I am not too concerned about whether you use reference angles or any other method that we've already done to get this, but this is faster for several people. As always, please let me know if you need any help.